For more than 40 years, Voyager 2 has drifted silently into the void, leaving the warmth of the planets behind, crossing the distant edge of the solar system, and venturing into the unknown. Launched in the 1970s, it was a mechanical emissary of humanity, expected to fade quietly, its signal slowly swallowed by cosmic noise. But it didn't. Recently, Voyager 2 sent back something extraordinary, a sudden spike in data, a sharp shift that startled scientists, a confirmation of a truth long feared but rarely spoken. The edge of our solar system is not a gentle blur. It is a defined boundary, and beyond it, the rules change. When Voyager 2 passed the helipause, the threshold where the solar wind ends and interstellar space begins, scientists expected a gradual transition, a slow fade like mist dispersing. Instead, the change was abrupt. Radiation surged, plasma density jumped, and the magnetic field shifted sharply. One moment the spacecraft was inside the sun's protective bubble, the next, it was outside, in a harsher, more chaotic environment. The solar system, once imagined as floating serenely in space, suddenly resembled a fortress with walls that protect us from the galaxy's raw energy. The heliosphere, once considered a theoretical shield of plasma and magnetic energy, proved essential. Inside it, conditions are relatively stable, cosmic rays are reduced, and space weather is manageable. Step outside, and all of that is gone. Voyager 2 recorded surges in particle energy, chaotic magnetic fluctuations, and radiation levels far beyond anything near Earth. The textbook image of smooth, gradual boundaries was replaced with sharp spikes and hard numbers, revealing a solar system more precarious than anyone imagined. Even stranger, the heliosphere isn't static. It breathes, expanding and contracting with the sun's 11-year cycle. Voyager 1 and Voyager 2 crossed at different distances and locations, shaped by the rhythm of solar activity. The boundary isn't spherical, it's warped, almost comet-shaped, pulsing outward like a living organism. If the solar wind weakens, the barrier shrinks, allowing more galactic radiation to seep inside. If it strengthens, the shield expands. Our protection fluctuates. It can fail. And Voyager 2's crossing exposed just how thin this veil truly is. In 2019, Voyager 2 went silent for several hours. No commands were issued from Earth, yet all instruments went offline simultaneously. When it came back online, mission reports noted minor electromagnetic spikes and unusual particle energy just before the blackout. Was this a simple technical glitch, or had the spacecraft crossed an unknown zone, a region of space so foreign that its very presence triggered a reaction? Some scientists speculated it could be energized plasma, a supernova ripple, or an unseen interstellar shockwave. Others quietly wondered if Voyager had stumbled onto something entirely unpredicted. Once outside the heliosphere, Voyager 2 recorded fluctuations in radiation and plasma that didn't fit existing models. These weren't random bursts, they were patterned, rhythmic, almost like weather in interstellar space. Waves of energetic particles, sudden shifts in magnetic direction, and surges in galactic rays suggested that the space beyond the sun's influence is alive with dynamic forces, an unseen ocean of currents and tides. One of the most unexpected findings was the near-perfect alignment between the sun's magnetic field and the galactic magnetic field beyond. For decades, models predicted turbulence at this boundary, but Voyager 2 found synchronization instead. Either the interstellar medium had shaped itself over time to align with the solar field, or the galaxy's structure naturally accommodates it. Either way, cosmic rays could now flow more easily along these channels, challenging long-held ideas about interstellar interactions. Perhaps the most profound question is not what Voyager 2 discovered, but what it triggered. Was it merely an explorer, or has it become a signal in itself, revealing not just the universe but the presence of an intelligent species capable of understanding the patterns around it? Every reading, every transmission, every anomaly may be part of a dialogue we barely recognize. Voyager 2 has not just traveled outward, it has forced us to look inward, to question the nature of protection, exposure, and intelligence in the cosmos. The edge of the solar system is no longer abstract. It is a gate. A threshold into a violent, structured, and dynamic environment, one that measures what passes through. Voyager 2 has crossed it. We can only watch, listen, and try to understand the silent, complex frontier that awaits beyond.